Hi everyone and welcome to the new video. Today we will continue programming for the smart home and we will add an Airthings radon detector. First, what is a radon? Radon is a slightly radioactive gas that has no odor, no taste, so we naturally cannot feel it. Why it is important? Actually, radon is the first cause of the lung cancer after smoking. Radon is naturally emitted by the soil or by the rocks, so it can be found in every house, and that's why it's important to know its level. In this tutorial I will be using an Airthings radon detector. As you can see on the screen, it's a portable device that is pretty small. It works about 1 year from the battery and it can show radon levels, temperature, humidity, so it's pretty convenient. Let's see how it works in Python. First, let's test the cloud API. Technically it's easy and there's nothing so complex with that. We only need several lines of code to use the SDK. First I import the library. Then I need to specify the client and the secret that we can get from the Airthings website. Then we can get a client and first we can run and see if the device will be found. When the device is connected, we can get the list of its sensors. It's only several lines of code. And as we can see, it works. Short-term average, I think it's a 1-day average, and long-term average is while the battery is connected, so it's like a total value. And also as a bonus we can get humidity and temperature, so when you buy the radon detector for free you can also get the sort of weather station, which is also a nice bonus. But let's go forward. This thing works, but let's be honest, from the IoT perspective, calling the cloud API just boring. It's much more fun to work with real things, with real hardware, so I will show how to connect via Bluetooth Low Energy. First, as usual, we need to import required libraries. This code will be more complicated than the previous part, of course, because several libraries are required. As we can see, there is lots of things here going on. First, the Bluetooth library is using Async.io, so I need to include Async.io. Then we need Airthings device class provided by the Airthings company, the library called Airthings BLE, Bluetooth Low Energy. Then I'm using a Bleak library. I use it to find the device because first we need to find the device we're going to use. In Bluetooth Low Energy protocol, every device is advertising its data, so we can find the devices nearby. I will show how it works. First I need to specify UUIDs of the devices that I want to use. Otherwise there are too many devices around, like headphones, computers. Almost every device nowadays is using Bluetooth Low Energy, so there are too many devices. With this way I can only specify the list of devices that I need to find. I'm also adding the parameter of how often I'm going to read my device. We can read device more frequent, but it can drain the battery fast, so I specified the interval to 30 minutes. And our first method will be find device. As we can see in the code, I'm using the Bleak library. There is a method discover. Here I only need to specify the device UUIDs, and as a return value it will get the list of devices. We can see how it works. I will add the main part. And in the main part I will only add one line. Let's see if we can get it. I will enable the terminal. And as we can see, the device was found. This is my radon detector that I have. It's in the same room. So Bluetooth Low Energy works, and as a next step I will read the sensors. As I mentioned before, Airthings company provided the SDK for it, so there is not so much things we need to implement. This is actually only several lines of code. When we have our Bluetooth device, we need to create a detector instance, and when we call update device, that will actually read all the data. So as we can see, the logic is pretty simple, and all low-level code was already implemented by the Airthings. Let's change main a bit. I'm adding my code. And now we can see we are first looking for the device because the device can be turned off in theory. So first I add the device, and then when it's added I go to read forever method, and then I'm reading the data every 30 minutes. I will enable the terminal again and let's see how it works. Yes, now it works. We can see that we got all this data. We got our device, Carentium Home 2, and here we can see all our data, the temperature, 1-day average. Here we can also see the text interpretation, like radon level is very low. As we can see, the code works, and the next reading will be after 30 minutes. So Bluetooth Low Energy works, and we don't need the cloud API. We can read the device data. And now I will show how to add it to the Home Assistant. I will explain it very shortly because I already did it in the previous video. I will put a link here. For sending data to the Home Assistant, I will be using library MQTT Discoverable. This library is doing all the job for us. We create a sensor object, we send data to the Home Assistant via MQTT, and the data will automatically appear in the Home Assistant. First, I will create a data class that will contain all our data. I also created a helper class from device that will convert it from our Bluetooth data. And now I will create a class MQTT Radon Detector. I also need to specify the host. I'm using local MQTT, so I am not using a password here. And now I can create instances to all my 3 sensors. As we can see, I use a class sensor info for that. And I also added temperature, humidity, and the battery level. All the source code will be available in the video description, so you can check this later. Last but not least, I need to implement a data queue. The thing is that Bluetooth Low Energy works in async.io, and in async.io I cannot block the main thread, so the data will be pushed to queue, and this thread will read it from the queue, so the thread from async.io will not be blocked. Then I will implement the method run in background that is creating the Python thread, and here is the publish method that is pushing the data to the queue as I explained earlier. Now I will create the sensors, like for 1 day, for 1 week, for humidity, temperature, and battery. And the last code we need is read forever. As we can see, it's pretty simple. I get the data from the queue. If there is no data, we get empty. And if there is a data, then we just set the state of the sensor and the library will automatically send it to MQTT. As we can see, the code is a bit long, but the logic is pretty easy. We create the sensor and we only need 1 line of code to update the sensor. So I am adding this instance before the Bluetooth Low Energy, and in the place where we read the data I will add the call to the publish method, and the last one in the main code I need to run this MQTT connection in the background. As you can see, the code is pretty long, but the logic is simple. Let's see how it works. As we can see, our code is running and the MQTT thread is sending the data. And now let's see how it will appear in the Home Assistant itself. Okay, now we're approaching the final part and the most fun part. We can add our data to the Home Assistant. As we can see, the script is running, and if everything was done correctly, our data should magically appear in the Home Assistant. In this case, I am using the same machine, so it's an address localhost. And now let's add our data to the dashboard. In this part, no coding will be required. So this is my Home Assistant screen, and as we can see, the data already appeared here. I can see the humidity level reported by device, radon day average, battery level, and other parameters that were coded before. I can add the data to the existing dashboard, or I can create a new one. For example, let's create a new one from scratch. I can go to Settings, Dashboards, and we'll add the dashboard. It will be a new dashboard from scratch, and I will name it Radon. Now I'm opening edit mode. For example, let's say I want to add a clock on the dashboard. This is my clock. Let's add the visual graph. And I can add different colors. For example, let's add the historical graph. For example, I want to see the values for 48 hours. As an example of the second parameter, let's specify temperature. Let's move this graph a bit up. I think it may be possible to drag and drop. So as we can see, with only several clicks, I was able to create a nice looking dashboard. I think it can be possible to smooth this graph. I can add a radon day average here, because as a reminder, I send the data every half an hour, but if I smooth the data, it will look more beautiful. This is my more or less final dashboard, and as we can see, with only several clicks, I can make a visually beautiful interface. And of course, Home Assistant is technically much more powerful. We can add automations. If I go to settings and automation, and then as a trigger, I can select the entity. In the automation, I can specify the entity as a day average, and I can also specify the rule. For example, if the radon level is higher than a specific threshold, I can activate a smart plug that is connected to the fan. Technically, no coding is required, and you can investigate it on your own. That's it for this video. Thanks for watching. I hope it was useful and interesting. If you like this content, please press like and subscribe to see next videos. I will add more videos about home automation, MQTT, Home Assistant, and other topics. The source code for this project is available on my Patreon page. See the link in the description below. Thanks for watching and see you next time.